everyone, so I hope you all are fine. I'm Natasha and welcome back. So today we're going to continue our chapter number 1, and that is sets. So in the previous video we discussed about union of sets, and in this video we're going to discuss all about intersection of sets. So union and intersection, so they do make difference, like of course they're different with each other. So in union of sets, like we have to write all the elements that are in the sets, and we're only going to write all the elements once, okay? And but in intersection of sets there's something a little bit different. So in intersection of sets we only write the common elements. Like let's say we have two sets, set A and set B. And so what we're going to do in that is going to be that a set containing common elements that are in set A or in set B, like that are in set A and in set B is going to be the intersection of sets. Got it? So let me just write the, the definition. Of course, it's a statement. So first of all, we're going to write the heading, and then we're going to discuss about it. Okay, so first we have is intersection of sets. Intersection of sets. Okay, so intersection of sets, I'll say a set containing common elements that are in so a set containing common elements that are in set A, or let's say or in set B. Okay, well, yeah, no need to write set, so I'm going to write it again. In set A or in set B. Like basically, we're going to write the common elements that are in set A and B. So let me change it a little bit. So a set containing common elements that are in set A and in B. Okay, so like for now we have just taken two sets. Okay, so I take two sets as an example to show you. So that we can understand about intersection of sets in a simple way. Okay, set containing common elements that are in set A and in set B. So what we'll call it is called intersection of sets. Okay. Okay, intersection of sets. Okay, so now let's take an example. So, for example, I would like to take an easy example for, the topic intersection of sets. So, like, let's say we have set A and B, like, as I write it, as I'm, as I wrote in the, definition also, and now in the example also, I'm going to take the same sets. Okay, so set A is equal to the elements, okay. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, total 10. Okay, and in set B we have elements 2, 3, 5, and 7. All right. Okay, so in set A we have elements, like 1, 2, 3, 4 till 10, and in set B we have 2, 3, 5, 7 as the elements. Okay, yeah, so what do we have to do is we have to find A intersection B. And yeah, this is the symbol of B. I forgot to tell you the symbol of intersection, mainly used for it. So I'm going to write it right there maybe. Yeah, symbol of intersection is this. Okay, yeah, so it's like right opposite of union. Like in union we use this one, but intersection is this one, the opposite to. Okay, oh yeah, let's just drop this, we don't need it. Okay, so yeah, find A intersection B. So let's solve it. Okay, yeah, let's solve it. So, okay, so intersection of sets, we're only going to write the common elements in these sets. So we have only two sets, and then we have to write the common element. So first let's find that, which elements are in both the sets. Okay, so like 1 we don't have in it, 2 we have, 3 we also have, 5, okay, here it is, 7 right here. Okay, so I can see that A intersection B is actually going to be 2, 3, 5, and 7. Yeah, you'll be a little maybe you'll be a little bit confused, like it's actually set B is equal to the elements 2, 3, 5, and 7. But we notice one thing, that the elements which are in set A from 1 to 10, and we have in set B we have we have prime numbers. I can say this is prime number, isn't it? Like 2, 3, 5, and 7, and they all are prime numbers. And so in set A we have the natural numbers from 1 to 10, but in set B we have the prime numbers. So, and yeah, in set B we have the 2, 3, 5, and 7, and in set A we have actually all those elements. So that's what I did. So A intersection B is equals to the elements 2, 3, 5, and 7. So we find out A intersection B. That's it. But yeah, I want to tell you something else, that as we can see that A intersection B is equal to B, isn't it? Because their intersection is actually equal to B. Look, it's exactly same. All the 4 elements in it, all the prime numbers. First 4 prime numbers. Yeah. Okay, so A intersection B is equals to B. And one more thing, okay. Yeah, and one more thing I can say that, I've noticed one more thing, that can I say that A is a subset of B? No, it isn't, because we don't have all the elements that should be in set B. But set B is actually the subset of set A. So first thing was this. Second thing we have is that set B is a subset of set A. Isn't it? Because we have all the elements like 2, 3, 5, and 7. And 2, 3, 5, and 7, these all 4 elements are actually in set A. So 2 things we noticed is that A intersection B is equal to set B, and B is a subset of set A. So in the third one thing is of course common, that A is a superset of B. But this is common, like no need to write it, but still I'm still writing it. Okay. So, like the example, so I hope the example is clear to all of you, so that, that was the easiest example I thought to, tell you about it, so we can, clearly understand about intersection of sets. So now we'll move on to some properties, properties for, the operation of intersection, like we did, some properties of union, union of sets. So, some properties of the operation of the operation of intersection. Okay, so we'll have 5 properties in the operation of intersection. So first one we'll have is going to be the common one that we usually see, is the commutative law. So first one is going to be that A intersection B is equal to B intersection A. Okay? So, this is like basically common in union of sets and intersection of sets, in both. And so A intersection B is equals to B intersection A. Reason? It's the commutative law. The commutative law. That's common, and the second one is also common, it's actually that A union B, then union of C is equal to A union B, and actually I was saying it's union, but it isn't union, actually it is intersection. Yeah, A intersection B and intersection C is equal to A intersection B intersection C. So what's the difference? They're, taken in a group. So I'll say the intersection of A and B, then the intersection of C is equal to the intersection of, intersection of B and C. Okay. So A intersection of A intersection, the whatever we're gonna get in it. So it's true. So it's from associative law. Associative law, isn't it? Like these two are common in union of sets and intersection of sets. So let's take a small example, like just want to show you. Okay, so let's say that set A is equal to the same, the same case. I'm going to change a little bit, like set A is equal to the elements 1, 2, 3, 4, 5, 6, and 7. That's it. And set B is equal to, let's say 2, 3, 4, 5, and 6. And let's say set C is equal to the elements 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so what do we have to do? In first case, we have to do A union B and then, A intersection B, then the intersection of C with it. Okay, so A intersection B. So first of all, we're going to find the common ones. Okay, like we can see all of them are actually in it. So what I'll say is going to be, A intersection B is equal to 2, 3, 4, 5, and 6. Okay, and now the C, another intersection with C. So, okay, set C, in set C we'll have 2, 3, 4, 5, and 6. Oh gosh, it's really common. So actually, A intersection B is equal to, is equal to the elements 2, 3, 4, and 5, and 6. So 2, 3, 4, 5, 6, and actually the intersection with set C is also going to be the same. 2, 3, 4, 5, and 6. Now let's move on to our second one. That is going to be intersection with the intersection of set B and C. Okay. So now set B and C is going to be 2, 3, 4, 5, and 6, like the common one we have. So let's say 2, 3, 4, 5, and 6. And this one is also intersection of set B and C. Now the intersection with set A. So actually in set A we have also all the things at 2, 3, 4, 5, and 6. That's what we want. And so let's see, so we have seen that actually their answer is coming same. That we're having these same elements. So set A, so their intersection B, intersection C, and then their intersection with then. Okay, so it is equals to 2, 3, 4, 5, and 6. So as you can see, it's common. So like we can see that this is a true property. I can see. So yeah, we can also we all can see that the answer is true. The answer is same. So both the answers are same. So this is how associative law comes in the property of the operation of intersection. Okay. So the third one we'll have is going to be a little bit different from these two, and okay, so the third one we have is actually phi. So phi intersection set A is equal to set A. And set U intersection A is equal to it's going to be set A, and this is going to be phi. Yeah. Phi intersection A is equals to phi, and U intersection A is equals to set A. And it is from the, the law of phi and the law of universal set. As we all can see, isn't it? Like, okay, in set A we'll have, in set A we'll have phi, and isn't it? And so in phi intersection A is equal to phi, and universal set, so set U intersection A is equals to A, and these both are from the law of their own. So I'll say that, it's from the, so for this one, it's for the law of, it's from the law of phi, and this one law of universal set. To make it short, I will, write it like this way. That's so easy. So law of phi and universal set. That's it. Now let's move on to our fourth one. So the fourth one we have is actually idempotent flaw, which we have already discussed in previous video, union and intersection of any set with itself reward this same set. So what I'll say is going to be that set A intersection A is equal to A. Reason? Because it's from idempotent flaw. Idempotent flaw, isn't it? Isn't it true? Of course it is. It is same as in union of sets. And so now our fifth one. Now the fifth property we'll have is going to be a little bit different. That isn't in union of sets. Okay. Let's move on. So the fifth property that I'm going to write it will be here. Okay. Fifth property we're going to write is actually, let's take 3 sets. Set A, set B, and set C. Got it? And what are we going to do with it? Okay. So, yeah. I'm actually going to do their union with an intersection both. Okay, so it's going to be like this way. A intersection B union C is equal to A intersection B union A intersection C. Okay, have a look. Do you know? It's the property from distributive law. Of course it is distributive law, in which we have both union and intersection. So A intersection B union C is equal to A intersection B union A intersection C, and it is from distributive law. So what I can say is that the intersection distributes over union. Intersection distributes over union. So it is from distributive law. So let me write it also. Distributive law. So what I'll say is that intersection distributes over union. Okay, union. It's not set U, it's union. Okay. So that was all the properties in intersection of sets. So last one, I hope it's going to be clear to you. So what we're trying to say is that what I'm trying to say is that set A intersection of set A with the union of set B and C is equal to intersection of intersection A intersection B union A intersection C. Okay, so like after finding the intersection of set A and B and then the intersection of A and C, then we're gonna find do the union of A intersection B and then A intersection C. Okay, yeah, so that's all for today, and in the next video we're gonna continue after our set topic that we're doing. And so see you in the next video, and thanks for watching and have a great day.